Yeah, I think we are live. Just check. Mm, I'm not sure. Yeah, I think we're live.
Okay.
Yeah.
So do you want to go
Hi
ahead
everyone.
and
Yeah,
yeah,
hi everyone. So this is our first doubt discussion session for the Junior Bootcamp from Pathway. We have a section with us. So yeah, section. Like,
yeah,
I will hand over the stage to section. Yeah.
great. Thanks, Devansh, for the introduction.
Mhm.
A quick introduction before I move ahead. I am Saksham. I'm a recent IT Delhi graduate, graduated 2 weeks back. Um, I've been working as a DevRel engineer at Pathway since June, and I am in this space for 1 year. And this space is moving really aggressively, so we want you guys to learn and quickly adapt yourself to build production ready environments and not just make GitHub projects and not take it to the next level. So quickly moving forward to the session, I'll present my screen and in between I'll be taking doubts. So Devansh, you could also help me. I'm not able to see the comments right now.
I
You
think
can also
like
help
people are
me.
still joining.
Okay. Anyways, I'll start. But if you see that there are a lot of doubts
Yeah,
coming, then
I
you need
will.
to
Yeah,
uh,
mhm. I will let you
you
know.
just stop.
Yeah.
Yeah. So is my screen visible?
Yeah. Yes, it is visible.
Yeah. Okay. Great. So welcome to this bootcamp. I think we had a really great kickoff session with Mudit. Now talking about generative AI, we all know it's a subset of traditional ML. It's basically generating stuff. It's generating text. It's generating images. It's generating any multimodality you want to say. It's about really finding statistical patterns in massive data sets of content. So usually the way we interact with large language models is quite different from other machine learning or computer code paradigm. In these cases, we write prompts. We write in the natural language, that is English, or any other language you prefer, and we get our output in the same language or in different language. So large language models are basically trained on large corpus of data. So in this session, before moving forward and talking more about large language models or foundation models by various companies, I'll quickly give you the overview what the session will be covering. First of all, we'll be covering 4 modules today. Today, sadly, it's not the hands-on module session, but next week we'll have the session for that. So first, it's the basics of LLMs. What is generative AI? What is a large language model? What are the advantages and the various use cases of LLMs? What in general is the life cycle? I'll give you a quick hack also after the session that what a generative AI project life cycle looks like. And then module two comprises of word vectors. I'll tell you how exactly LLMs came into picture. What is the transformer architecture? I'll give you a quick overview since it really goes in deep into the NLP domain. But I'll obviously give you the why LLMs are into picture now and how it all started with few people from Google writing an amazing paper, which is attention is all you need. Obviously, you would have taken the graded quiz one. We'll obviously release the quiz two after the session. So now the next module comprises of prompt engineering, where I'll be talking about a few short prompting or how you can utilize the LLM knowledge in the context window itself of the LLM and improve your inferences, improve your prompt completions. Next, I'll cover the RAG and LLM architecture. And then obviously, once you know the basics of retrieval augmented generation, then in the next week, we'll build production ready RAG pipelines. I'll obviously tell you why RAG is important versus fine tuning and prompt engineering. I'll tell you the benefits of using RAG in the enterprise and production setup, which I think after you'll graduate, you'll be using in wherever, whichever companies you work with. They'll obviously ask whether you have built a production ready project or not. So I think it would be a good way to write projects in your CV or resume as well. So now quickly talking about large language models. So you know that large language models are trained on large corpus of data. There are various foundation models by various companies who are competing aggressively in this space. They want to top the charts. They want to top the benchmark metrics. Get ahead of other models in terms of evaluation, whether it's the task of summarization, whether it's the task of translation or information retrieval. So, various base models, you might have certain biases, like OpenAI has the GPT-4o, Meta has the Llama 2, which is an open source initiative by them. They also released Llama 3 recently. We have Google coming in by a various set of models in the Gemini series. And there are great open source startups like even Pathway who are competing in the open source. So first of all, talking about what exactly is a prompt and what exactly is a completion. Let's say you type in into the GPT that where exactly is Venus located in the solar system. Then the GPT will give you an answer that Venus is located after Mercury and it's the second planet in the solar system and before Earth. So basically, this act of using the model to generate a text is known as inference or a completion. And wherever the window in which you're typing your input is known as context window. So it's nowadays, with Claude, they have increased the context window to 1 million words, 1 million tokens. So I mean that's a great way where you can input even the entire book or let's say a course curriculum. So now talking about the advantages and applications of LLMs, let's say you're interacting with an LLM chatbot. What's the basic principle behind how an LLM operates? LLM operates by something known as next word prediction. So it sees the previous sentence, what you have inputted, and it outputs the next word, which has the highest probability or which has a higher probability, and it will output that based on what your input has been. So the various advantages over traditional neural networks is that it is trained on large scales of data. And obviously, I'll talk about the transformer architecture, where we are able to efficiently process and scale the data using multi-core GPUs. Obviously, transfer learning, once a model has learned lots of things from internet, it can obviously do great in other areas, other portfolios as well after knowing a few. There's contextual understanding, which was not present in the earlier models such as RNNs or LSTMs. There's obviously the capability of multitasking. It is able to handle diverse tasks. Like, let's say, if you want to summarize, let's say you want to translate, you want to do information retrieval, you want to search the net, where Perplexity AI comes into picture. There are a lot of use cases where an LLM could be beneficial. So now you see that the space is really moving forward, but you have a doubt how to create novel things. You want to say you want to create a novel solution based on LLM. How would you go about it? Then obviously you know that GPT has been trained at a certain point of time. I mean, they run batch systems, they continuously improve their models by incorporating new information, but you obviously cannot improve the LLM's knowledge in real time. So for that, you really need to build real-time systems which will revolve around processing the data which comes in real time, and then updating the LLM's knowledge base, and then you are outputting the answer based on the new documents you have uploaded. So combining real-time data processing with LLMs, I think, is the new novel way to create really good pipelines and which will give you an edge. So now what's the evolving scope of LLMs? It's how LLMs are able to handle multimodality and able to handle various types of input sources. So talking about the use cases, it could be you could use an LLM to write blogs, could be summarization, it could be invoking APIs and various actions and connecting to external databases. Now, quickly moving to the bonus resource we have for this module. It's basically how multimodality in LLMs was there and how it was able to unravel this mystery, and it was able to use various inputs which the user was giving using the LLMs. So this resource you can go through how, we could how the model takes in audio, it takes in the speech, it takes in images, videos, etc. Stability AI is doing really great by creating animated videos. You must know about. So the basic principle behind this is using multi-model embeddings or embedding models. I'll talk about embedding models in quite a while, so you'll get to know more about this. So before moving to the transformer architecture, do we have some doubts? I mean, Devansh, here you help me. Okay. Yeah. Which sort of API key are you using? I mean, which LLM you are using, Akhand Pratap? I mean, I would like to know that to answer more. So I think I am only able to see these many doubts till now. So we'll quickly move forward to the next module. So now talking about how LLMs work, how this whole thing buzzed and it's really moving forward. Basically talking about RNNs. RNNs is recurrent neural networks. From artificial neural networks, we really moved a pace by introducing RNNs. But what problem was with RNNs was that it was limited by the amount of compute and memory we needed to perform well at these generative tasks. So, as we scaled the RNN implementation to these generative tasks, we really need to spend a lot of money to significantly scale the resources the model has. So that would, really mean nothing if at the cost of billions and millions of money going into pre-training RNNs, then it's best that we move forward without it. And also, this thing you'll agree that English is a complex language and understanding this language can be challenging. Let's suppose I say I took my money to the bank. Here, obviously, and I know that bank is the bank like HDFC or ICIC, but for the LLMs who are computer machine could mean a river bank. So these homonyms could be really confusing to the LLM. So to teach these differences, these nuances to the model, we needed an architecture which was transformers. So basically, with transformers, we could scale the process efficiently. We could parallelly process the input line which the user said, and we really paid attention to the input meaning of the sentences. So basically, what do I mean by attention mechanism or paying attention to the input meaning? So it basically learns the relevance and context of all words in the sentence. Let's say you are saying the teacher taught the student with the book. So here we really need to capture the relevance of what teacher has to a student or what a student has to a book. And we really need to apply attention weights. Let's say teacher has a strong relationship with the student here than teacher has with the word taught, right? So here the model really needs to learn the relevance and uh, and apply attention weights accordingly. So you can go inside the maths portion where it's the QKV values and you can understand about the softmax function, calculating logits, and then getting the vector embeddings. This is for you if you really want to deep dive into NLP. I'd be happy to take doubts in the Discord channel if you have any. So for transformers, we have an encoder decoder type of architecture and we have multi-head attention. So there's not only a single attention head which will see to the various relationships, but we have multi-attention heads which pays attention to various types of relationships. Let's say a positional relationship with what the word teacher has to taught, because I gave an example, the teacher taught the student with the book. So here the teacher has some sort of positional understanding as well as some semantic meaning, which is the exact meaning of what teacher has to the word taught in the English dictionary. So these various relationships we need to understand. So here, that's why we used multi-head attention in this architecture. So how the architecture mechanism works is it converts the words into a word vector kind of thing. Why to convert into word vector is because this is a numerical format which makes the text accessible to LLMs. So it converts the words into numbers, with each number representing a position in the dictionary of all the possible words you have in your English dictionary. That specific word you have will have a specific vector index in the dimensionality. So what I mean here is, let's say you convert an input, and then you really want to see the token IDs is matched to the vocabulary in the multi-dimensional vector space. So what I mean here, you imagine a vector size of 3. You know that imagining a vector size of 3 would mean XYZ axes, where if you say the words student and book, they should be kept close to each other because they kind of have a strong relationship with each other based on the meaning. If you keep dog and cat, they would also be kept similar. And obviously, by similarity, I mean the angle between the vector they would have. The angle or the cosine would be small. So this was about word vectors and word vector relationships, what I taught you about. But these are great videos to really understand what word vector relationship mean. And uh, our advisor here, Anu, has really made these videos awesome for students to understand what vector embeddings mean and how to choose the right vector embedding model is through checking through the leaderboard, which gets updated quite uh, often. And then in the hands-on module, you see we use embedding ADA model, or we use the Gemini embedder to build applications, but you can obviously opt out to any open source Hugging Face embedded model as well. And you can see it in the MTV leaderboard. So now quickly moving forward to the bonus section here. This was a talk by our CTO who has worked with 2 or 3 godfathers of AI, and Lukash Kaiser, who was the writer of the paper Attention is All You Need. This is a great way to open and keep your minds boggling. Uh, it's a great talk, how the retriever works, how exactly is the future of LLM going, where exactly is the future of LLMs going, and it's a video which keeps your minds pondering about what's next in this field. And before moving on to the next module, I'll take some doubts. I see no doubts right now, so I'll move forward. So now we know Sam Altman said writing a really great prompt for the chatbot persona is an amazing high leverage skill and an early example of programming. And even the senior director at OpenAI, who is Andrej Karpathy, said that English is the next hottest programming language. So I think that's correct, and you should really get your prompt writing skills to max, because that's how you'll interact with these models, which are trained better than humans in various tasks. So if you need the best output, you really need to input the best. So now coming to prompt engineering, as I told, there's a prompt. Once you input the prompt into the model, and then there's the response. So this act of getting a completion from an LLM is known as inference. Quickly moving forward to in-context learning. By the way, you can refer to the resources by Mike Chambers from AWS, who has really interactive videos by explaining what in-context learning is. But if I really want to explain you in a short way, it's doing, if let's say you are inputting, if you want to do sentiment analysis, let's say, and you want to classify a review, and the review is I love this movie, then what's the sentiment? It's obviously positive. But with a large language model, it's easier for the model to input the answer based on a zero shot inference. But if you take a smaller model, then the sentiment could be neutral, because the small LLM is not really great at sentiment analysis. So if you provide an example first and then you input your question, let's say you say, classify this review. You say, I love the movie. The sentiment is positive. And now you say, I don't like pizza, when the sentiment is negative. But before directly jumping into the question, you give an example first and you teach the LLM what importance of in context learning is there. So even the importance of this is you really not need not use a large model. but you can use a smaller model, but give one or two examples, and you can really output correctly. So this way, the model learns from itself, from the context you have provided, and it outputs the answer. But I mean, these techniques only work if you can give around 5 to 6 examples. After that, you'll really have to work on fine tuning, and the in context learning or prompt engineering will not work. So for starters, it's a good practice that you input a question. If you input an example of what task you're doing, and then you ask the question. In this way, the model learns from the context and then outputs the best answer. If after writing 5 or 6 examples, even the model is not giving the correct answer, then you really need to fine tune that model on that specific task. By fine tuning, I mean additional training, additional supervised, traditional ML supervised training to the model by fine tuning on specific data sets of knowledge. So yes, this was about uh, talking about various token limits as well, because you might have run into the error if you try copy pasting a long Wikipedia article or an archive paper. The ChatGPT says that the message was too long. So here we have done a comparative analysis for you, that how GPT-4 model has a token limit of 32,000, but Claude 3 or 3.5, it has increased its token limit above um, 1 lakh tokens. So that's a great way to improve how much text the user is inputting. So you can go about the understanding how this comparison and see what model fits best for your use case. As you all know, there are problems with LLMs. There are hallucinations, basically where LLMs tend to deviate from what they were supposed to answer, but make up their own knowledge. For that, there's a great technique of uh, making the model stick to the relevance of the query by introducing an architecture which is known as RAG. Now, for RAG, it's basically you have let's say, a long research article. Now, you want to query based on that research article. What you do is you take the article first, you split it into chunks. Let's say a document contains 1,000 words, 1,000 pages. Then you split according to 200 words each. You have 1,000 words in an article, and then you have five splits, five chunks, and then those chunks are embedded into embeddings, like the vector embeddings, which I told, which is basically a vector matrix. And then you obviously embed the query, and then you run the similarity search based on those vector embeddings. So that's how RAG works in the greater picture. And then you see which part of that chunk is closest to the answer, and that will be gone into the large language model along with the query, and then it will answer based on the chunk which was the most semantically similar to the query. So that's how the entire RAG architecture works. But obviously, it's not that simple. There are great ways. There are various components of RAG. Let's say starting from document parsing to document splitting, to making vector embeddings and storing it into a vector database. Now that's also an important point where you need not store those embeddings somewhere, but you can directly use pathway as a vector store, or various vector search libraries which utilize various techniques of calculating the semantic distance like KNNs, etc. So this is how RAG architecture came into place. So now a quick overview of what's the difference between let's say uh, RAG and fine tuning LLMs. RAG is, you can obviously see this video, but RAG is what I explained to you, and fine tuning is additional training. So you might not have resources, you might need to work on an organization level first with RAG, and if the performance doesn't improve, then you say that yes, we really need data sets to fine tune our model further for this particular task. Let's say if you are handling a customer service request for a tech company, then you really need a model to classify it based on various sets of queries. Let's say if it's a server problem, or it's a backend problem, or it's a coding problem. Then according to that, you can fine tune a model based on customer service requests. But that's not the main aim here to talk about fine tuning because it takes resources. But what's best is to first utilize RAG and then slowly move on to fine tuning. So general overview in summary is first to define the problem. What's your use case? If it's summarization, you can go into Hugging Face. You can see various benchmarks that which model is the best for this particular use case. And then after this, you adapt and align the model according to various techniques. Let's say you want to do prompt engineering, you want to try zero shot or few shot prompting. If that doesn't work, then you go to RAG, where you input a private external data source into your LLM and then do it, or you do fine tuning, or you do reinforcement learning with human feedback, which is RLHF for short. And then after this, after we have chosen a particular method you want to go with, then you evaluate your model. You check your model, you inference your model with various sets of queries and whether your model is hallucinating, is it still hallucinating, or is it getting better? And then obviously after you have done this pilot step, you really need to move it to production level or for cloud deployment, where you optimize and deploy the model for inference. And that comes into the whole LM ops pipeline, ML ops pipeline, DevOps field. And you augment the model and build LM powered application. So that's the entire GenAI project lifecycle, which is needed you to build and get success in this field. Yeah. So I'll stop here. It's if you have any queries, I'm open to taking that.
Think we do not have any other queries. Uh, I think we can take up a few general queries that people are having on the WhatsApp group the or Discord server. Like one thing that some of the people are asking that are the quizzes like is there a deadline by which the quizzes need to be covered up or completed, or like they are once the quizzes have been released, they can be completed by the end of the bootcamp. Uh,
Saksham, you want to take that?
For the deadlines, I think it's better if you respond with it here.
Okay, okay, cool, cool,
okay,
cool.
yeah,
Basically, the context is see, um, the earlier you attempt, the better, because when you submit the quiz, you get an email with the next set of steps to follow. But then we do see that there are some people who keep the quiz on the back burner and keep it for the last moment. Keep, let's build the project first and then we'll attend the quiz at the last.
mm,
So it will be open till the last date when you see the project submissions open. But the earlier you submit, the better, because yeah, you'll get that email. And
okay, yeah,
also, like, we push the quiz release date to today. We wanted to release it after the session, so it will be live in a couple of hours. So you can find it on the same link.
great.
Yeah.
I think
Um,
when I guess apart from this, we have a query
will the
with a
notebook
notebook
be
link.
available after the bootcamp as well? Are you referring to a specific
I think he's
notebook?
talking about like they're talking about the Git book
Yes, it will
that
be.
we
Yeah, yeah.
have.
You have to spend time to make notes and all those things. Yeah, good book. Yeah, thanks, Pranjal. Yeah, it's basic. It will be available. Yes.
Mhm.
Yeah. In fact, yeah, you can also take it as an inspiration to write your own tech blogs. Interestingly enough, it's an area which helps you open up opportunities. Basically, it's an easy way to attract attention from players in the industry. You notice something, you notice a tutorial which is written, you feel it could have been explained in a better manner, go ahead and do that and publish it on towards data science, Medium, LinkedIn. And then yeah, for example, if it's with Pathway and you end up publishing it and then tagging Pathway, it's very obvious that we'll take notice. Like, very likely we might come across it, and then we will, like it, we'll share it. So those, in those ways, what happens is that you naturally become visible to pathway team members, to other folks and all. Now tomorrow when you have to apply for pathway any other company, you can certainly use that as a reference link, that you know what, I did this is what was attraction, and it's a good way to attract attention. So those things can also be done. Yeah, we've seen people do that. It's a very commendable stuff to do. So just sharing that suggestion as well. And the next steps that here in this journey involve, basically we're understanding RAG. Uh, we have understood basics about vectors. You've understood transformer architecture to some level. Go through those modules. If you're having these sessions, you have time, then go and spend those extra hours after this to go through the bonus sections and at least understand whatever is possible. If you feel it is becoming too overwhelming, the good news is that nothing in the bonus section is needed for you to be able to build the project, even in real world like production applications. But then it's very helpful for you to know as an engineer. Okay, so you can cover those if you have time. Go and understand those things, and possibly also help out your peers on those lines. And then after this, once you have understood about vectors, about LLMs, and all those things, we'll understand RAG in a very basic way. Now RAG as a field is also evolving quite a lot. It came initially with the Facebook paper. I think it was Facebook only around 2020, and then it has been evolving since. Okay, for example, as Saksham mentioned, like we use vector search here. Like you understood vectors, right? Basically representing this in a numerical format. Then folks came and said, why you just use vectors? How about you combine it with something like Google search, which is basically something like Elasticsearch, BM25, and all those things. You combine this, make it a hybrid stuff like a super saiyan kind of thing to make it perform better. Now the systems that you're seeing right now, they are delivering much higher accuracy with something like a hybrid index. So we'll also see an example of that. We'll see how we can build it now. And interestingly enough, if you have to get opportunities as a developer, well, let's say in the freelancing domain or as a founder, you would notice that there are some, you don't necessarily always need to push the boundaries of what exists, but do something really really well and solve a meaningful problem. For example, building things with open source models, private rack is a huge requirement of companies. No, but no, like most companies today, they don't want to send data to OpenAI servers or Gemini servers. They just hate it. Even if they say in privacy policy that you buy subscription from us, you go for the business version, we won't use your data. In the fine print, they have written in some places that they may use it for XYZ places, and that makes companies really uncomfortable. They are like, okay, no, we'll only go with Mistral, we'll only go with open source, or like they have the choice of models, or they would rather want to go totally open source. So we'll also see how to do that. And towards the end, we'll culminate this bootcamp with you being able to build a RAG project that solves a problem. Okay. There's a point by Pranjal, as we have the midterm exam here. What about the project submission deadline? It's far more better if after MT. So when is the MT starting exactly?
It's actually starting from 9th of September and like it will end at 12th.
Okay.
Like I
So
had communicated like this to you. So I think we
yeah,
can
yeah,
shift it by a week, I guess. It should be
yeah, yeah,
sufficient
exactly.
enough.
Yeah, we can do that, and we can also, like, something that we've done in other colleges in the past, like if there's an examination, we can kind of have a break in between and then resume after
Mm-hmm.
that. But you have to be the one motivated enough to come back after the break and finish the project. The projects will be verified, you can use it. In fact, today only I was approving projects from a few other students from other ITs who are using it apparently for their placements and all. So you have to be motivated enough to reach that point. But then yeah, we can take the break. That's not much of an issue. Yeah. If you build the project early on, like, you can try to optimize it even further. Like, there's no push from our, don't take extreme stress. Build your foundations, cover the bonus resources if possible, and then go. That's also an approach that you can very well take. That's fine. Yeah. Go through the modules, don't try to skip them. Many of us become slightly excited about the idea of implementing things hands on, and we skip the theory. The theory is there for a reason. It's not the same stuff that is communicated elsewhere. So you should go and read it to understand what's really uh, some of the ways in which you can leverage your skill set in the best manner possible. So go and spend some time there is what my recommendation would be on top of it. Yeah. Cool. Then I think we have no other questions. Thanks, Pranjal, by the way, for highlighting it. Thanks for those who asked the questions. Um, yeah, cool then. Yeah. Devansh, by the way, you're on mute in case you're speaking anything.
I'm audible now.
Yeah, you're audible now. Yeah.
So, I guess if there are no more questions, we can end the session for now.
Okay,
Yeah.
cool, cool. Yeah, sure.
No other
And
questions.
we and one very small shout out and request. If you've not started the repos already of Pathway, you should go ahead and do that. It's your way of showing support to our community initiatives. It also helps us like make a point that yeah, we're actually helping folks. The community is liking what we're doing. So when you go and start, it's your way of joining the community and also showing your support. So do go ahead and do that. I think you can find the links for the repos very easily. Just search for LLM space app GitHub. You should find it that way, or just search for Pathway.com. The website is pathway.com, but the organization name on GitHub is Pathway.com. So you can search with that and go ahead and start the repos. That's it. Yeah, that's my shameless plug towards the end. And yeah, that's it. Thank you, everyone. Yeah.
Thank you, Anil, for the session. It was great having both of you.
No problem. Thanks, Devansh, for having us. Thanks. Bye, everyone.
Thank you
See you
so
soon.
much. Bye.